All right, good morning and welcome, class. Make sure you grab your whiteboards, your whiteboard markers, and your erasers. And then go ahead and have a seat. We're going to get started on your bell work. I have two problems on the board today, which are going to review your multiplication and division facts. Okay, so I want you to go ahead and get going on those. We have 375 multiplied by 36. Two-digit number. We have our division problem, 24 divided by 586. I'm going to give you a few minutes to go ahead and get started on that. Okay, make sure you get your whiteboards, whiteboard marker, and eraser. Okay, we're going to go ahead and look up at the whiteboard and get going on our bell work. Okay, remember we're multiplying by a two-digit number, okay? And we're dividing by a two-digit number. If you need your multiplication charts, we have some up front in the bin to help you with your multiplication facts. Okay, about 2 more minutes and we'll go ahead and we'll get started on going over the bell work. Okay, couple more minutes. Okay, Joshua, remember, we're going to go ahead and multiply by 2 digits. So it's very important that our numbers are lined up. Okay. Robert, we're dividing by 2 numbers. Okay, we're going to make sure everything lines up. Check your multiplication. Okay, we have our multiplication charts up front in the bin to help us with our multiplication facts. Okay. Okay, about 1 more minute, and I'm going to go ahead and stop everyone, and we'll do the problems on the board together. Okay, 1 more minute. All right. Let's go ahead and take a look at problem number 1. Okay, 375 times 36. Okay, so what are we going to do first? Emmerich. Good. Okay, we're going to multiply the 6. So 6 times 5 is what, Emmerich? 30. Put the 0. We're going to carry the 3. Okay. Then we're going to multiply 6 times 7, which gives us 42. Okay. Now what do we do with the 3 up here? Robert. Yes, we're going to add it. So 6 times 7 plus 3 is 45. 6 times 7 is 42, plus 3 is 45. So I'm going to write the 5, carry the 4. 6 times 3 is 18, and then we know we have to add the 4. So 18 plus 4 is, good, 22. Okay, so we're going to write 22. Okay, now we have to do what? Who can tell us what's next? Mariah. Okay, good. We've already multiplied the 6. So now we have to go ahead and multiply the 3. Okay, so I'm going to put a 0 here just as a placeholder. 3 times 5 is 15. carry the 1, okay. 3 times 7 is 21, plus 1 is 22. I'm going to write 2, and I'm going to carry a 2. So 3 times 3 is 9, plus 2 is, everyone? 11. Good job. 11. Okay, so I'm going to go ahead and add this together now. Okay, so 0 plus 0 is 0. 5 plus 5 is 10. So I'm going to put the 0, carry the 1. 2 plus 2 is 4. Plus 1 is 5. 2 plus 1 is 3. And then 1 plus 0 is 1. Okay, now we have something left that we have to do with this number. Okay, and it tells us the value of this number. Can anyone tell me what that is? Gabriella. Good. We have to put a comma in there, okay? So where is our comma going to go, Gabriella? Okay, we have ones, tens, hundreds, thousands, 10,000s. So where is what two numbers is our comma going to go in between? Good job. The 3 and the 5. Who can read me this number? What is the value of this number? Edward? Okay, Edward says 13,500, and that is correct. We have ones, tens, hundreds, thousands, 10,000s. Okay, so 13,500. Okay, good job. Let's go ahead and let's take a look at our division problem. Okay, so we have 24 divided by 586. How many times can 24 go into 58? Okay, 2 times. Okay, so we're going to put the 2 above the 8, and I'm going to put a little X here. Okay, we didn't divide 24 by 5, we divided 24 into 58. So therefore we put the number above the 8. So 2 times 24 is what? 48. So we're going to put the 48 under, and we're going to subtract. So 8 minus 8 is 0. 5 minus 4 is 1. So we're left with 10. Can 24 divide by 10? No, because this number is bigger than the 10. So we're going to go ahead and we're going to bring down the 6. Okay? Now, can 24 go into 106? Yes. How many times can 24 go into 106? Okay, good. 4 times. Okay, so we're going to put the 4 above the 6. 4 times 24 is what? Who can tell me what 4 times 24 is? What did you get, Aiden? Good. All right, so Aiden says 96. And that is correct. Okay, now we're going to subtract 106 minus 96. 6 minus 6 is 0. Okay, we have to borrow. Okay, so 10 minus 9 is 1. We take away the 1 that we borrowed, and that brings it to a 0. Okay, so we are left with 10. So how do we write that? 24. Good. Remainder are 10. Okay, so 24 divided by 586 is 24 remainder of 10. let's go ahead and let me show you what that looks like, okay? So to check our answer, we can take 24 multiplied by 24, okay? So 4 times 4 is 16, carry the 1. 4 times 2 is 8, plus 1 is 9. Okay, we're gonna put a 0 down here as a placeholder. 2 times 4, again, is 8. 2 times 2 is 4. So when we add that, we get 576. Okay, so we have a remainder of 10. So we're going to add that 10, and we now have 586. Okay, so our answer checks. Okay, all right, good job with the practice. Okay, so today we're going to talk more about equivalent fractions. Yesterday, when we worked on this, we kind of struggled a lot with equivalent fractions. I looked over the worksheets and quite a few of you had some troubles, but we're going to go ahead and we're going to continue talking about them again today and do a little bit more practice, and you'll have another worksheet. But it's going to look a little bit different than the one that we did last time. Okay. So again, the goal for today's lesson is to understand fractions as numbers, specifically recognize and generate simple equivalent fractions. Okay. So we know that a fraction is a numerical quantity that is not a whole number. Okay. A fraction is split by a numerator and a denominator, okay? And just to give ourselves a little refreshment, the numerator is always the top number above the line, which creates a fraction, okay? The denominator is the number below the line in a fraction. So if we look up here at the whiteboard, 2/10, okay? 2 over 10, 2/10. The 2 is going to be our numerator, okay? Again, it's the number above. The 10 is going to be our denominator. Okay, and that's our number below. So the numerator is the top number, and the denominator is the bottom number, okay? And equivalent fractions are fractions that are equal in value, but have different numerators and denominators, okay? So remember that, okay? So I'm gonna pull some problems from the worksheet that we did yesterday that you were to turn in to be graded, okay? I'm gonna pull some examples from there, some of the ones that we really struggled with, okay? So we have two circles. Okay, the first one. Okay, the first circle is going to be split into 8 sections. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And our second circle is simply going to be split in half. Okay, I'm going to shade our circles accordingly here. Okay, so we have our 2 diagrams. Now we have to label them using equivalent fractions. So if we look at the first diagram, we said we have 8 parts, right? 8 total parts. How many parts do we have colored or shaded? Briella. Okay, we have 4, right? 1, 2, 3, 4. Okay, so we have 4 shaded parts out of how many? Did we say? 8. Okay, so this diagram, the first one, represents 4/8. Okay, and they're saying that this is equivalent to this. So it's the same thing. When we look at diagram number 2, we notice we have how many parts total? 2. Okay, we have 2 parts. How many of those parts are colored? 1. Okay, so in this problem, 4/8 is equivalent to 1/2. Okay, so if you look at the diagram, and we did this yesterday, you'll notice that even though this circle has 4 parts, it still equals the same on this side. Okay, so these 4 parts, if you were to draw a line past both sides of the circle, you'll notice that these 4 parts are the same as 1/2. 4 of these equal 1/2 of the circle. So 4/8 equals 1/2 is equivalent to 1/2. Okay? Let's try another one. Let's look and understand one more. Okay. All right, so let's do, okay. Oh, this is a good one. Okay, so again, we have 2 circles. And let me fix this a little bit. Okay. On this side, we have so when we look at these 2 diagrams, what are our fractions going to look like? What are these diagrams representing? Okay, if we look at the first one, we have how many total parts? How many total parts do we have? Joshua. Okay, we have 3. Okay, so we put 3 on the bottom because that's our total number. Okay, total number of parts. Okay, how many of those are shaded? So how many parts out of the 3 are shaded? Emmerich? 2. So that's going to be our top number. Okay, and that's going to be shaded parts. Okay, now when we come over here, we have how many total parts? Well, let's count them. 1, 2, 3, 4, 5, 6. Okay, so we have 6 shaded out of how many total? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6 shaded out of 9 total parts. Okay, so 2/3 is equivalent to 6/9. And again, if you look at the diagrams, okay, so we have kind of like this triangular line here. Everything above it on this one is shaded. If we do the same thing here, if we make these lines thicker, and we'll extend them past the circle so you can see the area I'm talking about, everything above is shaded. So it's the same thing, okay? So 6/9 is equivalent to 2/3. So it's the same thing. It's just these 2 parts are split into smaller parts, okay? All right. I'm going to go ahead and do a problem with you, or do a problem from your worksheet. We're going to do one together, and then I'm going to go ahead and set you free to finish the rest of it by yourself. Once you're finished with your worksheet, again, as usual, it's Chromebooks. So ST Math, Let's Go Learn, okay, and I'll walk around the room and give any assistance that I can, okay? All right. So on your worksheet, we're going to kind of do the opposite of what we've been doing. So we've been using the diagrams and coming up with our equivalent fractions. Today we're going to do the opposite, and maybe this will help you understand. You're going to be given the fractions and the diagrams, but you're going to have to color in the parts. Okay, so let's do one together. Let me do one for you. So 4/8 is equivalent to 2/4. And we're still using the same diagrams. Okay, we're using the circles. Okay, so I'm going to split this into 4/8. Okay, so remember, the denominator is the total number of parts inside the diagram. So we want to split this first circle into 8ths. Okay, and then the second one needs to be split into 4ths. Okay, so if I have 4/8, okay, and we said 8 is my total number of parts, then 4 parts represent what's shaded. So I'm going to go ahead and shade or color in 4 of those 8 parts. Okay, so 1, 2, 3, 4. And over here, we need to color in 2 parts. Okay, because my total is 4, but what I'm actually coloring in or shading is 2, because we said the numerator is how many we're going to shade. So if I go ahead and shade 2 parts out of 4, this is what it's going to look like. Now, when you look at both of these diagrams, what do we notice? That they're the same, exactly. So the first diagram is just split into smaller parts. But again, if you look from this point around to that one is the same on both. We've just taken these two and broke them down into smaller parts. So 4/8 equals 2/4. Okay? Now let's do one together. I'll try to remember these because these are being pulled from the worksheet that you're going to work on. Okay? Okay, let's kind of do something similar. Let's see. Okay, so 1/4. Okay, 4 represents what? Briella. Right, the total amount of parts we have. So we have 1, 2, 3, 4. 4 parts make up this whole entire circle. Okay, what does the 1 represent, Richard? Good. How many parts we need to shade? So we're going to take and shade 1 part. That's it. 1 out of the 4 parts. Okay, and that represents 1/4. Okay, so this is showing 1 out of 4 parts. Okay, now let's move over to this side. 2/8. Okay, so what is the 8 telling us? Edward? Good, that there are 8 total parts in this circle. So let's go ahead and count them. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if the 8 represents the total number of parts, what is our 2 telling us? Gabriella. Right, how many we need to shade? So we're going to shade 2 out of the 8 parts. Okay, so I'm going to go ahead and shade my 2 parts. Okay, now again, if we look at the diagrams, okay, I'm going to extend this line out here. And I'm going to do the same thing here. If we look at these, we'll notice, okay, that the same part is shaded on both. Okay, so really 2/8 equals 1/4. 2 of these parts equal 1 big one. Okay, so this 1 part, okay, can be broken down into 2, can be cut in half. So 1/4 equals or is equivalent to 2/8. Okay, all right. I'm going to ask that everyone go ahead and return their whiteboards, whiteboard markers, and erasers, and grab a pencil, and the worksheets are up there. I'm going to have you grab a worksheet and go ahead and get going on that. I will go around the room to assist anyone that needs it. And then when we're finished with our worksheets, we'll go ahead and put those in our folder in the back of the room, and we'll get on our Chromebooks to do ST Math or Let's Go Learn. Okay, everyone knows where they stand with their goals on those two. Okay.